This is Euclid Book 3, Proposition number 7, and this is a very long proof, so there'll be more than one part to this, okay? First of all, Euclid wants you to draw a circle. As you can see, it starts here at point C here, it goes through point B here, goes through point A here, comes back around, all the way around, goes through point D, and goes through point G, and finally comes back up to C. Okay, so far, so good. Now, Euclid wants you to draw a diameter. Well, the diameter starts at point A, which is on the circumference of the circle, goes through point E. In this case, it also goes through point F, but then it will finally end at point D. So AD is the diameter of this great big circle. But Euclid's not done with you yet, because he wanted you to draw this point F randomly on AD, which we have done. Okay? And then he wants you to draw a line from F to B, from F to C, from F to G. Now what he says is that by the end of this proof, we're going to prove that the length of FA is greater than the length of FB, and the length of FB is greater than the length of FC, and the length of FC is greater than the length of FG, and the length of FG is greater than the length of FD. Whew. Well, what does Euclid want you to do first? Well, he wants you to draw some NOR lines. Draw a line from E to B, E to C, E to G, and, of course, we already got this line from E to D. All right. Now, Euclid, first of all, says that by Book 1, Proposition 20, that the sum of the lengths of EB, well, here's EB here, the sum of this length here, plus the length of EF, which is right here, these two lengths added together are going to be longer than FB. Okay? Then he says that AE and BE are of equal length because all radii of a circle are equal. Well, here's AE here. This is AE. And this is AB. AE, AB. They're equal length. And because of that, we can actually say that the length of AF, which is this great big length, starts here at A, goes all the way to F, is greater than the length of BF, which is right here to here. We can say that safely now. Alright, Euclid then says that BE is equal to CE. Well, here's BE, right here. It's equal in length to CE. And then he goes on to say, and of course BE and CE are equal in length because all radii of a circle are equal. Then he goes on to say that BEF is greater than CEF. Well, where's BEF and CEF? Well, BEF is this angle right here, BEF. And this angle right here is CEF. And he is literally saying that angle BEF is greater in size than angle CEF. And he goes on to say that angle line BF is greater in size than line CF. Well, here's BF here and CF here. And the reason why BF is longer than CF is because of Euclid Book 1, Proposition number 24, and I'll let you look that up. Euclid then goes on to say that the length of CF, here's CF right here, is greater than the length of FG. And Euclid justifies this again by Book 1, Proposition number 24. You can look this up for yourself. Then Euclid goes on to say that line GF here and line FE here, if added together, are going to be longer than the length of EG. And he justifies this by Euclid Book 1, Proposition number 20, and you can look that up for yourself. Then Euclid says that EG is equal to ED. Well, here's EG here, and here is ED here. They're both the same length because of all the radii of the circle are equal. So that means that the sum of the lengths of GF, here's GF here, we add that length there to the length of FE, and when we do, we get a number that is bigger than EG. Okay? or actually ED. Okay, sorry about that. It's not only longer than EG, but it's also longer than ED because EG and ED are both the same length. So the sum of GF and EF are longer than the length of ED. Whew. All right, now here comes the fun part. We're going to subtract this FE right here from both GF and from ED. And when we do, then we can establish that length of GF is greater in size than the length of FD. And by doing all of this, we have now finally established that the length of FA is greater in size than the length of FB, the length of FB is greater than size than the length of FC, the length of FC is greater in size than the length of FG, and the length of FG is greater in size than the length of FD. But this is not the end of the proof. We will deal with that in the next lesson, so stay tuned.